All right, well, welcome. My name's Ron Kraus. I work with Marion Soil and Water, and I am your state Oregon Envirothon coordinator. We're going to put together some videos for you that will help explain some of the equipment that we use during the competition. Today we're on the Little Pudding River in the Willamette Valley of Oregon, and we're going to be taking some water samples on this lovely stream and see just how polluted the Little Pudding River is today. We picked the Little Pudding because it has some problems with pollution. If we took a very pristine stream, we wouldn't find much as far as pollution levels. We're going to take these readings and measurements of the stream water and compare it to the state standards for salmon and steelhead to see how this stream compares. This is the same thing you'll have to do during the competition with the same equipment. Let's take a look at our equipment first. We're going to be looking at dissolved oxygen. These are Chemet kits, and you will see how they work when we get into this. We will also be looking for nitrates. We will be looking for phosphates. We will also be taking temperature and pH. First thing we need to do before we can get started is we need to take a water sample. So we're going to walk down to the creek over here and fill up our water sample the same way you will do at the competition at the Oregon Garden. Okay, let's go. All right, this is a side channel of the Little Pudding River. As you see, we can see a little bit of flow through here, not much. This water comes off of agricultural fields, so it generally has a high amount of nitrate and phosphates depending on the time of year. This is the end of September, so we haven't had rain for a while, so we're not sure what we're going to get today. When you take your water sample, one of the most important things is to get your water sample without any excess oxygen. So what you're going to want to do is take the cap off, take your jug here, very carefully put it in under the water all the way and let it sit there for a moment like that, and then take your lid and you cap it underwater. There should be no air bubbles when you're done. So we've got it capped. We didn't collect any excess air, and you see I have absolutely no air in my jug. So now we're going to take it back and we're going to do our samples. The equipment we're going to use today to test our water samples are called Chemet kits. They are a vacuum tube that makes it very simple and quick to do a water sample. We're going to be testing for these 5 things. We're going to test for dissolved oxygen. We're going to test for nitrate. We're going to test for phosphate. We're going to take a temperature sample, and we're also going to test for pH. We are going to compare those to the state standards for water quality for salmon and steelhead. And we'll see how this creek here at the Little Pudding compares to those state standards. Okay. All right, we've got our water sample. What we're going to do first of all is we're going to check temperature. For temperature, pretty simple. You just open up your sample. That of course has no air in it. We're going to drop the thermometer in. Doesn't get simpler than that. Leave it in for a while. At the same time, we're going to test for pH. These are eco testers. They're electronic. You take the cap off and you will see that it has a glass probe in here. That is what actually measures the pH. You turn it on by the bottom button and the LED will light up. You submerge it into your water just about a ½ inch. Doesn't have to be too far. And you will notice that the numbers start moving, and you move your pH tester around a little bit, swirl it a little, and you watch those numbers until they stop moving. We're at 8.2, 8.1, 8.0, and it may take a little bit, and it doesn't seem to be moving anymore. And it is stabilized. I can press the hold button and take a look at it, and it says it is 8.0 right on the nose. So be sure to turn your tester off so as not to waste the batteries. And we're going to record this information on our whiteboard. So what we're going to test for today is temperature in Celsius. We're going to test pH. We're going to test dissolved oxygen, or DO. We're going to test for nitrates, and we're going to test for phosphates. Right now our pH is 8.0. We'll leave the temperature thermometer in there for a little bit. But the next one we're going to do is dissolved oxygen. So we take our dissolved oxygen kit, open it up, and you will notice you have a vial. Okay. You have indicators, which we'll use to measure our pH, and we have inside the Chemetz box, we have the vacuum ampule. These are filled with a reagent, and you will see that there's a little reagent in here. This is a vacuum. It's also scored at the tip. When we break that off, the sample water will fill up and react with the reagent to give us our sample. That's why we call them vacuum ampules. So what we want to do is very carefully, without stirring up my sample, fill this to about the 25 milliliter mark with our sample water. Careful not to stir it up. You take your ampule and you put it in like this and apply pressure to the side of the vial. Oop, and it broke, and you will see that it is immediately turning color. Rock it back and forth so it mixes. And this doesn't have to set for very long, just about half a minute. And then what we do is we compare it to our chart. And I set it up like this. We'll take this out. And I move it along until it matches. Obviously doesn't match here, but as we get up here, ooh, it looks like it's about a 10, between a 10 and a 12. So we're going to call that, what do you think? Let's call it a 10. So we're going to say that this water right now has 10 milligrams per liter, or parts per million, is the same thing, of dissolved oxygen. Pretty simple. That's why we like to use these kits. Put your ampule back in there. We won't need that anymore. And we'll record our dissolved oxygen as 10 parts per million, or milligrams per liter. All right. We can probably test our temperature now. So we'll pull out the thermometer, and we read the thermometer in Celsius, and it is right at 22 degrees Celsius. So for our temperature, we will write that down. 22 degrees Celsius. Very good, we're done with those. We will move on now to test our nitrates. All right, we are now going to test for our nitrates. So we've opened up our nitrate Chemet kit. Same situation applies. Here is our measuring indicators. We have 2 sample bottles, a top, some acidifier solution. Inside the box we have some reagents in foil packets. And like before, we have our ampules. So we'll take out an ampule. Set that there. We will take out 1 foil packet. And set that there. Now, for this, we start out with our sample, and you will see it is also graduated. We want to fill this up to the 15 milliliter line. So we'll put the top back on our sample. And we fill it up to 15 milliliters. I'm a little high. $15 milliliters, exactly. Exact. Take our foil packet, open up our foil packet, put the refuse here, don't throw it on the ground. Squeeze the edges together, pour in your reagent, cap it, and now you shake it vigorously for 2 minutes. 2 minutes exactly, no more, no less, so I hope you brought your watch. All right, our 2 minutes is just about up. You will notice that there is still a little bit of powder in there. That is a zinc reagent. And that's okay if it all hasn't dissolved, but a good share of it should have. All right, so what we do now is you get your acidifier solution, and in your empty 25 milliliter cup, like we used for the dissolved oxygen test, you put in the empty cup 10 drops, exactly. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Cap it so you don't spill it. And then you want to carefully pour in your solution. And if you get a little of that zinc powder in, it's all right, but you want to try and leave the zinc, as you can see the zinc in there. Leave that in the bottom of the tube. And we'll clean it out when you're done. All right, same business applies. You use your vacuum ampule. Set it in like so. Apply pressure to the side. Snap. It's sucked up the sample, moving it back and forth to mix it. If it changes color, you know you have some nitrate. Obviously, we have nitrate. If it doesn't change color, you have no nitrate, and that is what we want in good water. We then again use our color comparator here, and we compare the color Ooh, it's not quite a 3. I'm going to say it's almost, looks to me, between a 2.5 and a 3. I'm going to call it, use my best scientific judgment, I'm going to say it's a 2.75. Okay, put your used items in there. And we're going to go over here to our whiteboard. And our nitrate is 2.75 parts per million, which is the same as milligrams per liter. You are correct. So we did find some nitrates. We'll discuss our results when we're done. Next, it is time to move on to the phosphates. All right, finally, we are going to do our phosphate test. Again, our Chemet kit this time has 2 color comparators. This is a high range of 1 part per million to 10. This is our low range color comparator, which goes from 0, 0.1, 0.2 up to 1.0, which relates to this. Depending on the amount of phosphate we have, will determine which of the comparators we use. You again have a bottle, sample bottle with a lid, acidifier solution as before, and vacuum ampules, and we will take out 1 vacuum ampule. For this, we take and we use 25 milliliters. You will see the 25 milliliter mark. So taking your water sample, fill it up to the 25 milliliter mark. Looks like I got a little bit of duckweed in there, but that won't hurt anything. A little too much. 25 milliliters exactly. For this, you put in 2 drops of your acidifier solution. 1, 2. Again, cap it before you proceed. Put the black cap on it, and we shake it. And for this one, we shake it for to mix, just to mix. Sometimes I even need to look at the directions. All right, it is mixed. And by now you should know the routine that you take your vacuum ampule, apply pressure to the side of the vial, snap, and mix. For this one, I have found it's wise to let it mix for a little while. You will see that we're starting to get a little blue color. Not very much. So to start out, I compare with the high range color comparator. It's definitely more than 1. But it's not quite 2. It might make it to 2. I'm going to say, what do you think? We'll say it's 2 parts per million. There, it's starting to change. If it was lower than 1, what you do is you take this and you slide it in like that, and then look through it this way up to the sun and compare it with the ones around it as you look through this way. But it's definitely more than one, if you can see that. So we're going to say it's 2 parts per million, or milligrams per liter. What we're going to do now is we are going to compare our results with those of the Oregon standards for water quality for salmon and steelhead. We have Class A, Class AA, and Class B. Class AA is spawning water. It has to meet these criteria. Eggs will develop nicely in water with these parameters. Class A is holding water. Salmon can live in it, but development of the eggs would be questionable, primarily because of temperature and dissolved oxygen levels. Class B is migration water. Salmon can easily pass through it, but they would have no success at spawning. So you would expect Class B waters around Portland and through the cities. Class A as you get farther upstream in the mountains, and Class AA in the actual spawning beds in the upper reaches of our rivers. In our water here in the Little Pudding is 22 degrees Celsius. To even be classed as Class B, it has to be less than 21. So we will give this a C grade because it didn't even make B. This is classified as a 303D stream because of its temperature. That's a state rating that says this water is unfit for salmon and steelhead. It'll be interesting to compare these results with what you test in your stream. Our pH is 8. To be classed as AA, it has to be between a pH of 7, which is neutral, and a pH of 8. 6.5 to 8.5 for Class A. So amazingly, the pH here does receive a AA rating because it's right at 8. Any higher and it would be classed as an A. Dissolved oxygen is at 10 parts per million. If it's greater than 11, it can be AA. It didn't quite make 11. It's 1 part per million short. However, it does rate as a Class A because it's greater than 8 milligrams per liter. So this stream receives an A. Our nitrate is 2.75. If it's less than 1, it can receive a B. But our nitrate is extremely high. It probably will get a D, if not an F. Our phosphate is at 2. Phosphate is the same thing. If it's less than 1, it can receive a B. So we're also going to give it a D rating. So if we look at our results, we say, what is the overall rating of this stream? You could say, as some do, that, well, if it averages out, maybe it's a B. But it doesn't work that way. When you give your stream a rating, you always give it the worst rating that it receives. So the overall rating for this stream, we're going to say, is a D. It cannot be any higher because these are your limiting factors. For this stream, we have 3 limiting factors for salmon and steelhead. Temperature, but really it's pretty close to being a B. However, the nitrate and phosphates are extremely high. Those for this stream are your major limiting factors. For most streams, you will not find nitrogen and phosphate this high, but we picked this stream just to show you the results and how the tests work. I would hope that whatever you do at your school, that you will have much better results than this, as the Little Pudding is one of the most polluted streams in our state. That's why we picked this stream. So the take-home message for this is to remember that when you rate your stream on your test at the Envirothon, you have to give it the rating of its lowest limiting factor. In this case, it would be nitrate. With that, I hope you've been able to follow us along, and now take your test kits and go to your local stream or waterway and be sure to practice yourself, and I'll see you at the Envirothon.